Hello all, we are learning the subsystem. Just now we have finished with the what is subsystem, why we are using subsystem and main two types of subsystems. And now we will learn about that little more about that two types of subsystem. Okay. So these are the virtual and non-virtual, which we can say as this. Non-virtual is also known as atomic and virtual is known as non-atomic subsystem. The virtual subsystem offers a graphical hierarchy in model, while they don't play an active role in a simulation, where the non-virtual subsystem that is not virtual has execution and graphical hierarchy model. Non-virtual blocks plays an active role in simulation of a system, where a virtual subsystem plays no active role in a simulation and does not affect the simulation result, where the non-virtual subsystem plays an active role in the simulation of the system, complete system. Okay, so virtual system also known as non-atomic subsystems, where the non-virtual subsystem is also known as atomic subsystem. Virtual subsystems represents a grouping of a block that can execute in any order, where the non-virtual subsystem represent a physical grouping of a block that can execute in a specific order. That in execution order will be specific only. So the virtual subsystem provides a way to organize and modularize a model by introducing additional level of hierarchy, where in the non-virtual subsystem, the blocks within a non-virtual subsystem execute sequentially in the order they appear. A virtual subsystem is a subsystem that is not a conditionally executed subsystem or an atomic subsystem, where in non-virtual subsystem types include the atomic subsystem, model reference, variant subsystem, and variant model ADC. So let's get learn about more with some example. Okay, so here you can see I have created two logics. Okay, these two logics are like one is having the four input, one addition and subtraction. Okay, and second one is like use only for like addition, and the output of the addition use as a subtraction. Okay, here you can see now. Fine. So how we can create a subsystem? We can directly create subsystem from library browser, selecting in Simulink ports and subsystems. We can select the subsystem and create the subsystem. Inside that subsystem, we can implement the logic. Or else, if we have already created the logic, then how we can create a subsystem? For which logic we have to create a subsystem? That's the important question. So here, for this logic, I have to create a subsystem. For this logic, this is my logic. Inputs I didn't want, outputs I didn't want inside a subsystem. I want above the subsystem only. So I'll select this logic. After that, you can see the three dots are created. In that three dots, we have create subsystem, create enable subsystem, create trigger subsystem, create function call subsystem, or like comment or logic, or create a area, or like auto route, or like we can have various ways to do something or another operations as well here. Okay, after selecting, I am doing simply the create a subsystem. Okay, now you can see my subsystem is created with the four inputs. Okay, I'll change the inputs if we want, but my main motive is to show the execution order of the subsystem. Okay. Now, again, for this logic also, I will do the same thing. Okay. Okay. So, now for this logic also, I will create one subsystem here. Okay. Or this is also the subsystem. So what I will do, I will delete this output. Okay, I'll delete this input, and I'll take this input from the output of this. Is that fine? I can take. There is no issue to taking with this as well. Okay, fine. And here I'll be able to say this thing. the output of these two. Okay, where if I want to see the display here, I'll take this display here as well, and I connect this to display here. Now, the same operation should be performed here and there everywhere. Okay, you can see now. I'll take this inputs are here. All inputs are one only, so output will be maybe addition of 1 plus 1. It's become a 2. Okay, here you can see I have a logic of 1 plus 1 into 1 into 1. So 1 plus 1 become a 2 and 1 into 1 become a 1 itself. So here the output will become my 2. But once you'll come here in that same logic, here 1 plus 1 will become a 2. Okay. So here 1 plus 1 will become 2 plus 1 become a 3, and here 3 into 1, my output is 3. Okay, in that way it will work. So first I'll simulate this model in front of you. You can see the what output we thought that all outputs are coming. One. Okay, here the 3 and 3, and here 2, and output is 1. 1 into 1, that output is 1. Fine. Now, if you know what kind of subsystem is this? This is a normal virtual subsystems. This is a normal virtual subsystem. And how you get to know that this is a normal virtual subsystem? Okay, what I will do for your simplicity, okay, I'll create the exact replica of this logic here one more. Okay, I'll create the exact replica of this logic one more for our simplicity and for our better understanding. Okay, where I'll change these two subsystem to atomic subsystem and two subsystem to the virtual subsystems. Okay, now you can see here these subsystems are normal subsystem, like virtual subsystem, where no execution order will perform and all this thing. Okay, it will be used only for the design simplicity. So how can we make our virtual subsystem into atomic subsystem? So for that, what you can do, you can right click on this subsystem, come to the block properties of subsystem. Okay, here you will get option treat as an atomic subsystem. You can make it apply and okay. So now you can see the changes here. Okay, changes here. What are the changes? This is a normal subsystem which is having a light color border, but atomic subsystem, you can see that border color is changed now. It's become red. For this subsystem also, I'll make it this subsystem as a atomic subsystem. Okay, atomic subsystem, apply and okay, fine. Now you can see if I simulated a model, this will also give the same output. Here doesn't matter with the outputs. Okay, we want to see the execution order. For that, I'm coming in a debugging information overlay here. Here I have a tab for execution order. Okay, if I am selecting this execution order, and now you can see how my simulation is run with what kind of execution. First, my simulation is run with this logic, this complete logic. Okay. Here you can see how my inputs are treated. Okay. First, initially, it got the execution order of 3, it got the execution order of 13. Here you can see first my all addition operations are performed. 1, 2. Okay. 1, 2. After that, this got a 3. After that, this here, that our addition of this is got a 5. And this inputs got maybe 4 and 5 or 4. Okay, this third input got a 4. Okay, first addition will be performed in complete way, and here this is got a 6. After that, you can see that 7 is this for this, and 11, 12, then multiplication is performed. And inside it, you can see I have two different orders to perform this 5 and 8. Okay, but if I am coming here where my subsystems are atomic subsystem, so you can see 15, 16, 17, 18. Okay, these all treated as a single entities in a one shot. If I am coming inside it, you can see these are treated as 19.1, 19.2. So what happened? First, perform this. It is firstly perform this. Then secondly, it's taken the input of this, then perform this subsystem. At end, he is given the outputs for us. But here, if you saw, if it's a non-virtual subsystem, right, if it's a virtual subsystem, it's perform first addition, given the output, then it's perform the multiplication, then it's given the output. But here that complete subsystem is also not treated as a single entity. But here you can see that my complete subsystem is treated as a single entity. That's the important difference between the virtual and non-virtual subsystem, that also known as atomic and non-atomic subsystem. So this is my atomic subsystems where I have checked the option treated as atomic, these two with same logic, and these two are my non-atomic subsystem, means virtual subsystem. In this difference only we got this line very first. Okay, you can see virtual subsystem also known as non-atomic subsystem, and non-virtual subsystem also known as atomic subsystem. So this is very important difference. Everyone must remember about this, the difference, how that execution orders will work for this. You can think about that. And what will happen? What will happen when why we want the atomic subsystem? It's very helpful for a code generation. Once we will generate a code, that complete logic should be treated as a single entity inside one main function. Even if he created addition separate function, multiplication separate function, but that both functions should be called here in a single function. In a single function. But what will happen here? It will not work in that way. So code will become much more complex. Okay. And that output, understanding of output is also become much more complex with virtual subsystem. So that's why we use non-virtual subsystem atomic systems. Okay, so that's all about that virtual and non-virtual and atomic subsystem. Okay, if anything else there, then we will learn in some next classes about this. Important thing is like we have to understand the difference between the execution order. Okay, and a few more things like unless and until there is a real need to make the subsystem as an atomic, it is recommended to have as many subsystem as a virtual subsystem to have a better optimized performance. Okay, that's fine. Okay, so that's all about that virtual and non-virtual subsystem. We will learn some new type of subsystem in next class. Thank you.